a lot of my presentation is actually going to be related to the things that that you kind of heard about as part of that debate. So hopefully it can shed some light on those things if you didn't understand all of it. This is also a technical talk. So if you're not technical, I'm sorry. But hopefully I can get through it in a way that is understandable to everybody. All right, let's get started. So before I get started, what is Everclear? I mentioned I'm Arjun. I'm one of the co-founders of Everclear. Everclear is a system that is trying to figure out how to coordinate the settlement of liquidity between chains. We are trying to solve what is called the rebalancing problem for intent solvers. Basically, intent solvers need to go and move liquidity between chains as part of rebalancing their inventory in order to be able to continue solving transactions. And the way that Everclear, at least Everclear's hypothesis around how to do this, is that we have this multi-sided marketplace where we net down solvers as coincidences of one. So you have a bunch of solvers that want to move liquidity between a bunch of chains. We can net that down into one finalized flow. And by doing that, it reduces the need to bridge altogether. Everclear is growing really fast. We launched our public beta about 6 months ago, 5 months ago. And then we've basically been doubling in size every month, which is pretty awesome, except for January, which was a little bit of a dubious month. And in that time, we have also basically been driving fees down to effectively zero. So right now, system fees on Everclear are sorry, this is supposed to be 0.37 basis points. So yeah, you can see how this is basically just tending towards becoming effectively nothing. And this is what we believe needs to exist in order for us to get to the point where solvers can just go and fill transactions wherever without having to think too much about where their liquidity is. This talk is a little bit more high level. It's about fragmentation. And as we all know, fragmentation is really the biggest problem that the space is facing today, and is the biggest reason why we're all sort of going back and forth with Solana. Ethereum has expanded into this 101 chain ecosystem, 181 chain ecosystem. And with this extremely fragmented ecosystem of bridges and interoperability. There's just a ton of different strategies, and every different ecosystem goes and says, hey, we are solving fragmentation by doing X, Y, Z. And I want to try to dive into some of the reasons why that's the case. So what is fragmentation? At the end of the day, fragmentation actually comes from a fairly simple process, and it comes from this original sin of Ethereum design, which was that ERC20 as a token standard was designed for a single state machine. Ethereum was not designed to expand to many chains, and so when we were designing ERC20s, we didn't really think about minting and burning those ERC20s in a standardized way between different ecosystems. And so instead what we do is this fairly simple, fairly common process where we deposit ETH into some sort of container on L1, which I'll just call a deposit contract going forward. And then we use that to connect to some messaging protocol and mint a representation of that ETH on another chain, right? Basic stuff. The problem happens when you have many different chains or many different bridges, because then you have multiple deposit contracts on L1 that go and mint multiple different representations of ETH on different L2s. And these representations are not fungible with one another. And the reason they're not fungible with one another is because each token that is minted on an L2 is fundamentally a pointer, right? It's a pointer to funds that are somewhere else on L1. Now, this actually still exists even when you have burn and mint tokens. The only difference is that the deposit contract is 0x0. But other than that, from a technical perspective, it's really the same thing, right? Ultimately, what this means is if you really want to do interoperability the right way, if you want to mint and burn this asset the right way, in this case ETH, between chains, the only way to do it is exit it out of this chain, transfer it on L1 to the new deposit contract, and then mint it on another L2, right? Obviously, we don't do this. We don't do this because it's awful, right? Exiting takes 7 days, then you have to incur L1 gas fees. And so instead, we basically just obfuscate this with liquidity, using intents, using liquidity-based bridges. It's effectively the same thing. But we remove the need to have to think about this by holding a pool of funds on each chain that you can then transfer over. But of course, that has limitations, which is, one, that costs a lot of money and potentially takes time and has security risks. And two, it's limited on size. You are limited by the liquidity that you have. So kind of what Angus was saying earlier, if you wanted to transfer $100 million in ETH between these two chains, the only way to do it is through Ethereum. You can really see how salient this problem is with CCTP and USDC. So USDC is in this really, really interesting place where If you are in CCTP land, everything is magical and perfect. You can go between CCTP-enabled chains without ever having to think about liquidity at all, because USDC is just burned on one chain and minted on another. Right? There is fundamentally no real like pointer that you have to think about there. It's like the USDC is just completely liquid between ecosystems. But then the moment you exit out of that, right, you go from Arbitrum to ZK Sync, now you have this like entirely separate ecosystem of chains where you do have the like traditional process to mint USDC, and you get USDCE. Now the reason that this is broken is that you kind of have this like fragmented backbone for the asset, right? If I am an intent solver that wants to solve a transaction and get rebalanced between chains like Base and Arbitrum, then it's a really easy process. But the moment that I involve ZK Sync, even if Base or Arbitrum is like one of the chains, even though I can mint and burn USDC there, I'm bottlenecked by the kind of like lowest common denominator, which is what is the other chain doing? And if the other chain cannot support burn and mint, then you have to use liquidity everywhere. So this actually still forces everyone to build USDC pools on every chain. Right? As a bridge, you're not out of having to, like CCTP does not solve your need to have to build liquidity on Base. It just means that in some cases, in some pathways, liquidity is solved. This is basically path-dependent fragmentation. TLDR, deposits are really all that matter. Right? The L1 deposit contracts, at the end of the day, are the thing that really matter like when it comes to interoperability. If we want to solve interoperability, we have to figure out how we can actually get all of these deposit contracts to work with each other in a way that makes sense. And this actually brings us to an interesting conclusion, which is like we're all kind of building the same thing still, but in a slightly different way. Right? Messaging protocols, L2 frameworks, RAS providers, shared bridges, AgLayer, everyone is doing exactly the same thing, which is coming up with their own deposit contract for how they are going to go and mint and burn assets across chains, right? In this context, right, Layer 0 is competing with Arbitrum Orbit. It's competing with Superchain, which is competing with Gelato, which is competing with AgLayer. And it's unfortunate because I don't think they necessarily want to compete, but because everybody is competing on who owns the deposits on L1, you just end up in this world where things just remain fragmented. Of course, hypothetically, intents solve this, right? But not really. As I kind of mentioned earlier, intents let us like abstract away this whole like complex shit show from the user and instead move it over to the solver, which is this like magical being that somehow has 100% knowledge of how to like move funds between chains. But really what you've done is you've just like shifted over onus to someone else, right? Like this is a slide that we use pretty frequently, which is that intents are this game of like interesting hot potato where like you have this like fragmentation problem that users normally own, and then users kind of toss that hot potato over to bridges, and then bridges toss it over to solvers, and solvers toss it over to sexes and like market makers and other kind of liquidity people who have to then figure out how to deal with the problem. And ultimately, all you've done is just like band-aid over it and pretend it doesn't exist, right? Unfortunately, this is part of why interop isn't solved. So how do we actually fix fragmentation? And this was kind of getting into this question that Lamps was talking about, which is like, like base layer fragmentation. How do you actually address this? At the end of the day, intents don't really solve it. They let us obfuscate it from the user. But it doesn't seem like messaging really solves it either because no one can agree on which messaging system to use. So what can we actually do here? Well, option number one is we all somehow magically agree on a messaging system to use. Everybody collectively decides we're all going to give up on any form of sovereignty whatsoever. We're going to kill the superchain. We're going to kill layer 0. We're going to kill Hyperlane. We're going to kill our AgLayer. And instead, we have some Ethereum enshrined and also every other ecosystem enshrined deposit contract and messaging system that everyone just uses. Obviously, this is not going to happen. And unfortunately, what happens is that every ecosystem comes up with this idea independently. And so they're like, layer 0 is like, well, we're actually doing this with OFTs for these assets. And then Superchain's like, well, we're doing this with Superchain for our ecosystem. And so you end up in like this like systematically worse place where you now have this classic meme. And we are still in this conundrum at the moment. Like every single time someone proposes a new solution, this goes from like 15 to 16 to 17 new standards, right? Option number two, and this was something that I kind of proposed a couple of years ago, is like we find a way to still have one shared deposit contract, right? So the liquidity on L1 is no longer fragmented, but we allow for there to be multiple different messaging systems. And this introduces some complexity, which is like now this deposit contract is aggregating the risk of all of these messaging systems. So like if one of them gets hacked, they all get hacked. We tried to address this with XERC20, EIP 7281, by saying, well, you can just add rate limits to each of these messaging systems. But this also introduces a secondary conundrum, which is like, well, who decides what those rate limits are? Right? It works if you're USDC or USDT, where you're a centralized like token issuer, and you can decide, you have an entity that can decide how you want to structure your risk. But what about for ETH? You know, do we require Ethereum to hard fork to decide rate limits? It'd be really weird. I think people would not like that. And so this doesn't really work in all cases either. And then you have option 3, which is based rollups. And in based rollups, what you do is you say, okay, we're no longer going to have any of this whatsoever. We're not going to have L2 sequencing. We're not going to have any interaction with all these like clearing between the different messaging systems. We're actually just not even going to have, like, we're not going to have to think about deposit contracts whatsoever, because all of it is going to be a part of L1 block building. The L1 block builders are just these like, this like master race that can just go and do whatever they want on every single connected rollup, as well as Ethereum, all concurrently, synchronously within an Ethereum block. This is really fucking awesome. And it does work. Unfortunately, it still suffers from the same problem, which is it doesn't work everywhere, right? You still have to get like superchain ecosystem chains to be like, okay, we're going to give up our sequencer revenue. We're going to give up on our sovereignty. We're going to give up on everything that makes us an independent rollup ecosystem to buy into this system. And if not everyone buys into the system, once again, you end up in the same fragmented world. So far, I've only talked about problems. I haven't proposed any solutions. Unfortunately, this is the nature of building in interoperability. It's mostly problems and no solutions. Key takeaway, mostly problems and no solutions. I think the key problem is really that like the incentives themselves are kind of broken, right? Like for all of the different large-scale ecosystems that exist today around interoperability and rollup development, all of the rollup frameworks, all of the rollup as a service providers, all the messaging providers, their incentives are not to give up their sovereignty in order to buy into a shared ecosystem. It's just not going to happen, because it fundamentally means giving up any form of competitive advantage. It basically means like nationalizing your protocol into Ethereum. And unless everyone does it, it's sort of this like race to the bottom situation, right? So what actually should happen? And this is a proposal that we've kind of been thinking about for a while. Ideally, the way that it should work is that you should actually allow people to retain sovereignty. Messaging systems should be able to remain messaging systems. They should have their own deposit contracts, and they should not need to change a lot of what they're doing today in order to interact with a system that actually tries to solve this problem. And instead, you should have a system that just like plugs into what exists today and just negotiates between a bunch of different infrastructure. This is kind of how like the border gateway protocol works on the internet. So like this kind of a shit show to a much smaller degree happened with internet protocols as well. Of course, it was not fueled by tokens, which is just like an intense magnifier on any kind of fragmentation. But there is today a lot of fragmentation in the internet protocol space. There's a lot of different ways to interact with TCP/IP, and no one ever like coalesced on how we should do that. And so to solve that problem, there is an open interface called the Border Gateway Protocol, which is just a mechanism to plug TCP into localized protocols for interacting with Internet of Things devices, or for LAN, or for whatever, right? I think that we need something like that to exist within this ecosystem as well. Sort of a neutral kind of gateway, perhaps many neutral gateways that can compete with one another, that actually just go and almost aggregate all of these different systems with each other. What does that kind of look like? So this is something that we've been thinking about quite a bit, because it is quite interestingly related to how Everclear works, but it doesn't necessarily need to be. This is something that plenty of other people can build as well, which is a system that, aside from doing the like Everclear netting process that I talked about earlier, plugs into a bunch of different systems for settlement. And what it's doing is basically negotiating the relationship between messaging, so mint and burn messaging for like ETH on a given chain, to the underlying like collateral that is stored in deposit contracts on L1. In effect, this is sort of like having a system that's like has a bunch of working capital, and what it's doing is saying, I'm going to take a burn transaction over here that's happening with Hyperlane, and I'm going to connect that to a CCTP mint transaction that's happening over here. This provides the theoretically optimal outcome, right? Because you are burning an asset, burning USD, for example, bridged by layer 0 for a given ecosystem, which costs nothing. You are minting USDC on another chain, bridged by CCTP, which costs effectively nothing. And the only cost that you're potentially paying, is some cost of working capital in between to make sure that that happens, to minimize the need to have to do L1 transactions. But even that, I think, can generally be amortized to 0. Because over time, the need to even interact with these L1 contracts, as long as there is an asset, as long as there is backing for whatever asset that you're burning and minting, ultimately, at the end of the day, the L1 contracts, it's just a pointer to the L1 contracts. You don't ever have to interact with it anymore. To me, this feels like a good sort of bridge to get to, no pun intended, to get to the based rollup world, right? In effect, what you're doing here is you're taking the thing that's happening with based rollups, which is, or base sequencing, which is like, the L1 block builder is like negotiating interactions between all of the L1 deposit contracts and like clearing transactions between these different rollup systems. And instead, you're just putting that into its own rollup framework until we get to the point where all of it can actually be pushed into L1 block building. So it's a sort of intermediate kind of halfway step to get to that ultimate outcome. But the secondary benefit is that it ends up working with every ecosystem. So there's a lot of things that you kind of get out of this which are really nice. Thing number one that's nice is that there doesn't need to be just one of it. I think I've become very bearish on standards after trying to push a token standard now for several years and just getting ridiculous FUD around it. This doesn't need to be a neutral system. Oh, OK, I'm out of time. Anyway, some frequently asked questions. If you have more questions, come talk to me. This was my last slide anyway. Thanks, y'all.